we will discuss today some questions from the previous years of the from the alkyl halides and the aryl halide, that is they are also called as halogen compounds. Question 1 is, an unknown alcohol is treated with the Lucas reagent to determine whether the alcohol is primary, secondary or tertiary. Which alcohol is fastest and by what mechanism? So this is appeared in the 2013, that is the latest last year question. The options are given: tertiary alcohol by SN1, secondary alcohol by SN2, tertiary alcohol by SN2, secondary alcohol by SN1. In the Lucas reaction, what happens? An alkyl alcohol, when treated with a reagent, concentrated HCl in combination with anhydrous zinc chloride. This is called the Lucas reagent. In this reaction, the H plus will attack on the OH and goes out as a water. So what comes is a carbocation. So the more the stable carbocation, faster will be the reaction. So therefore here the out of the three different types of the alcohol, tertiary becomes faster reaction, and that too through carbocation is a SN1 reaction. So through carbocation is a SN1 reaction. So therefore answer goes to the tertiary alcohol by SN1. Option A is the right answer. Finally, we get a alkyl chloride which gives a turbidity, that is the test reaction. So the answer goes to the A option. So let's go to the question number 2. Arrange the following compounds in the order of decreasing acidity. The question appeared, this is also a latest question, that is 2013 year. So the question, that is 1 is parachlorophenol, 2 paramethylphenol, paranitrophenol, paramethoxyphenol. These are the 4 compounds as given. A chlorophenol, parachlorophenol and paramethylphenol, and the third one is a paranitro, and paramethoxyphenol. So what are the originally the phenol stabilizes, it's the anion, that is after donating the proton, phenoxide stabilizes, therefore through the resonance, therefore it is acidic. But the effect of this chlorine, effect of the chlorine here is the minus I effect. This is a plus I effect. It shows the plus M effect, but let us take minus I. So it is a plus I and plus hyperconjugation. This is a minus I and minus M effect. OCH3 shows minus I and plus M. So dominating is the plus M here. So these two are the plus groups and these two are the minus groups. So out of that, this comes number 1. Nitrophenol will become the number 1 acidic. Then the chlorophenol, the activating property of the chlorine. Then third, activating less will be the third. Activating more through the M effect, mesomeric effect, it is strong activating, therefore the fourth. So therefore the order goes to the paranitro, nitro after that, that is 1, 2, 3, 4, isn't it? So that is nitro 3 followed by the chloro 3, 1. So answer goes to the B, that is 3, 1, 2, 4. So answer B is the right answer. So let's go to the question number 3. The following compound on hydrolysis in aqueous acetone will give the 3 different answers are given. In this compound there are 2 different phenyl rings are attached through a 3 carbons are there and 2 phenyl rings are there. One of the phenyl is a activating group with the OCH3. The other side group is attached to the nitro group. The main is in the middle carbon there is one halogen. This halogen is substituting in a hydrolysis reaction. This Cl will go and next comes what? OH comes. That is the one answer. So that answer K is the right answer. And however, we expect one of the group like hydrogen or methyl jumps from here. When the Cl goes out, you get a carbocation, and the carbocation may be we expect this methyl to migrate so that a tertiary is formed. But here also there is a chance that the H minus migrates and you will get a 3 degree. And here also even if methyl goes 3 degree, but 3 degree is supported by this plasm effect through this OCH3. Therefore, this hydrogen goes there, OH comes here. So, in the first answer K, that Cl will go, OH will come. In the another answer, that is L, the H goes there and the OH comes here, that is another answer. Both answers are right answer. So, therefore, K and L, that is the answer A is the right answer. So, let us go for the question number 4. The major product of the following reaction is appeared in 2008. This is a 3 marks question, appeared in the EAPCET screening type examination. So, there is the compound containing a aliphatic carbon holding a functional group, that is the bromine is there. This bromine is allylic to the benzene, and there is another group is also there, a nitro group is there, and there is one fluorine is also there. This is treated with a reagent called what? A phenyl S minus. So, this is just like a phenoxide, thiophenyl compound is added. This is going to do the reaction on this one. This is specifically, it is mentioned in the dimethyl formamide, DMF it is. Under this condition, it shows a total inversion in the configuration, and then if it is a SN1 reaction, the answer should be the plus and minus 2 answers should be there. But all A, B, C, D are different compounds, only one compound you have to choose. In such a case, we have to go for the A, that is the total inversion, that the B, that is bromine has gone, and you will get a phenyl with the sulfur, the answer. The rest will be the as it is. The fluoro and the nitro will be as it is. So, that is option answer A is the right answer. So, let us go to the next question, that is 5th question. The statement 1 says aryl halides undergo nucleophilic substitution easy, and the statement 2 says the carbon halogen bond in aryl halides has partial double bond character. So, the statement 1 is correct because towards this nucleophilic substitution in alkyl halide, if you take it a nucleophile minus, if it is replacing, you are going to get a RN type of the compound, nucleophile substitution reaction it is. In this reaction, what happens if a compound is having a benzylic type, benzyl halides comes first, then comes allyl halides, then comes alkyl halides, within that alkyl also 3 degree, 2 degree, and then comes the vinyl halide, then comes the aryl halides, aromatic aryl halides. But what he says is aromatic aryl halides undergo easy, means that is totally wrong. Second statement is the carbon halogen bond in aryl halide. That's what the halogen shows a plasm effect. So, therefore, several times between the benzene and the halogen there will be double bond. So, replacing the halogen will become tough. That is, attacking nucleophile and aromatic is difficult, and cutting the double bonded nature halogen is difficult, and it is also nucleophile attacking an aromatic system is difficult. So, therefore, finally, the second statement is right, first statement is wrong. So, therefore, answer D is the right answer. Let us go for the 6th question. Statement 1, benzonitrile is prepared by the reaction of chlorobenzene with potassium cyanide. And the statement 2 says cyanide anion is a strong nucleophile. The first statement is benzonitrile is prepared by the reaction, that is the chlorine containing benzene. Nucleophilic substitution reaction is tough reaction. So, the replacement of this one getting benzonitrile is wrong. This statement is wrong. This is nucleophilic substitution, it is difficult. But whereas the cyanide is a strong nucleophile because HCN is a weak acid and whose anion conjugate base cyanide is a strong base. So, cyanide is a strong base, but it cannot substitute the aryl halides. If it is alkyl and if it is allyl benzyl type, its reaction will be favorable, but not on the vinyl and the aryl. So therefore statement 1 is wrong, statement 2 is right. So the answer goes to the D once again. So let's go to the question number 7. The statement 1 says bromobenzene upon reaction with the bromine and iron gives 1,4-dibromobenzene as the major product. So the statement shows that when bromine is there, introducing another bromine, next bromine goes to the para position. Absolutely right, because bromine is a plus M effect, though minus I effect is there, but it is a plus M effect. Directing property will be definitely goes to the ortho para. And statement 1 is right therefore. Statement 2 is in bromobenzene the inductive effect of the bromine group is more dominant than the mesomeric effect in directing incoming electrophile. Actually the bromine shows a minus I effect dominating over the plus M effect only in terms of the activating property, but not in the directing property. Directing property is based on only mesomeric effect, wherein mesomeric effect shows ortho para. So therefore bromine cannot shows a meta directing property, it is only ortho para directing. So therefore the statement 1 is true and the statement 2 is wrong. So the answer goes to the C. So let's go for the question number 8. The organic chloro compound which shows complete stereochemical inversion during an SN2 reaction is appeared in 2008. The first option is a secondary alkyl halide. Second option is a tertiary alkyl halide. Second one is also again a secondary dimethyl type of compound, and the last one is the primary, that is methyl chloride. So here what happens in this reaction? An alkyl chloride having a smaller groups like hydrogen, when you treat it with a nucleophile, the nucleophile prefer to come from the rear side because there is a delta minus on the chlorine. So therefore this will be influencing not to attack from the front side. So the nucleophile prefer to attack from the back side. As the 3 hydrogens are smaller one, between the 3 hydrogens it will come and slowly a transition state takes place, and then the compound undergoes a total inversion and the group's hydrogens will fall the other side. This is called a Walden inversion. This is possible when all the hydrogens are the groups attached to the carbon where halogen is there, that is groups are small. As the size of the groups increases, the back attacking or the rear attacking is not possible. It will undergo first ionization and then undergoes SN1 type of reaction. So therefore in SN2 reaction essentially the size of the groups should be smaller one. So the option goes to therefore D. So let's go to the question number 9. The question is methyl bromide when treated with a nucleophile. A methyl with a nucleophile answer is formed with the expulsion of that Br minus. The decreasing order of rate of the above reaction with the nucleophiles, a nucleophile minus A to D is given. Different nucleophiles are given. The A nucleophile is phenoxide anion, B is acetoxy anion, C is hydroxy anion, D is methoxide anion. Appeared in this is a 2006. So different the nucleophiles basicity in terms of nucleophilicity. In one way we can say the stronger the base, stronger the nucleophile, except in the halogens basicity nucleophilicity is reverse, but in general all the nucleophiles, stronger the nucleophile, stronger will be the base, or stronger the base, stronger the nucleophile, for which you can take all these compounds. Phenoxide is there, whether it is strong or not we cannot decide, but we can decide their anions after adding a proton. What comes? This becomes into a phenol, this becomes into an acetic acid, this will become into a methanol, this will become into a water. That is hydroxide is a conjugate base of the water, the methoxide is a conjugate base of the methanol. So in this if the stronger the acid, this is the stronger acid, this is weaker acid, this is almost neutral, and this is neutral, and this is little slightly basic in fact. So therefore much more weaker acid. This is if I say this is more weaker acid, this is the last one it is, in fact it is in the weakest acid, if you notice. Then the order will be the stronger acid anion will be the weakest one, and the most weakest acid will have the strongest base. This will be the strongest base, and the next comes the hydroxide, then next comes the phenoxide, then next comes the acetoxide. So the stronger the base is methoxide anion, so therefore order goes to the A. Answer A is the right answer. Let's go to the question number 10. The reaction of trans 2-phenyl 1-bromocyclopentane on reaction with alcoholic KOH produces a compound. That was A he is asking. So the compound is option A is 4-phenyl cyclopentane, 2-phenyl cyclopentane, 1-phenyl cyclopentane, 3-phenyl cyclopentane. The question is here, it is a cyclopentane containing 1-phenyl and the bromine is in the trans form. And what we are going to do is a removal of the HBr. Which bromine we are removing, it's very clear, this is the bromine. Which hydrogen is now? So we have that side we have one hydrogen which is opposite. This side hydrogen is cis. So the elimination will be always trans. So therefore, in fact, if the bromine goes this side, an alkene with the Serge rule product will be the generally we expect. But this side hydrogen is happens to be a cis. So therefore, bromine select the hydrogen which is the other side, and the answer will be the naturally it is an anti-Serge rule type of the answer will be formed. Phenyl will be there, but the double bond goes that side. Actually, if the double bond comes this side, that is Serge rule product. This is an anti-Serge rule product actually. Anti-Serge rule product. Because the product here, we are giving the preference that the transcoplanarity or the trans elimination will be the preferential elimination. So therefore, H and B are select from the other side, not from the phenyl side. So therefore, answer D will be the right answer. That is 3-phenyl. From the alkene side, it is 3-phenyl, 1-cyclopentene will be the answer. So let's go for the next question. 11th question. The structure of the major product formed in the following reaction is a question from 2006. The question is here, a benzene is given attached to a iodo compound, and there is another branch on which a chlorine is there. So these both the halogens are not same type. One is iodine, one is chlorine. Actually, outgoing property of the iodine will be the better in the aliphatic series. If you take the iodine will be the outgoing. So when you add sodium cyanide, the cyanide we expect this iodine will go first and you will get a cyano. But what happens here, this is a benzylic type. The halogen attached to the carbon, if the chlorine goes out, you will get a carbocation which is resonance stabilized. So therefore, though it is the chlorine, it will be preferable to substitute. So the corresponding answer will be the cyanide product comes in the benzylic cyanide will be the answer. The iodine will be intact. So this is the expected answer. So answer goes to the D therefore. So let's go to the next question, 12th question. Tertiary alkyl halides are practically inert to substitution by SN2 mechanism because of actually tertiary alkyl halides undergo faster reaction, but what mechanism? Mechanism is SN1 type of reaction. But here it is asked with reference to the SN2 reaction, the tertiary alkyl halides will not undergo almost SN2 reaction is banned are not possible on the tertiary compound because back attacking is totally closed. So therefore, it prefers to undergo through carbocation and then the reaction takes place. So through carbocation means you will get a cyclo, that is a carbocation, and then D and L type of the two inversion and the retention type of configuration type containing answers will be formed. But in this reaction, tertiary alkyl halide, he says it is inert because of the bigger the groups, the phenomenon is said to be the nucleophile cannot attack from the backside just because of what? Steric hindrance. So the answer goes to the answer A. So let's go to the next question, 13th question. The formation of the elimination of hydrogen bromide from 2-bromobutane results in the formation of So 2-bromobutane means we have a bromine here and we are eliminating the HBr, that is hydrogen bromide is eliminated, dehydrobromination. So in this reaction we have hydrogen from that side as well as this side. So either of these two can be eliminated. The principle says it's a strong base is used. According to the Sergeff rule, the compound having the more the alkyl groups, in turn more hyperconjugations will stabilize naturally the alkene. So therefore 2-butene will be the major answer. 1-butene will be the anti-Sergeff rule type. According to the Sergeff rule, this is 2-butene, that is answer goes to the C. Next question, 14th question. In the chemical reaction, a nitro compound, amino compound, it's an aniline. Aniline reaction with sodium nitrite, HCl and heating, that gives a diazonium compound with the HbF4. That means a mixture of HF and BF3 combination. When you add, a fluorinated diazo compound will come. That compound on slow heating gives a fluorine introduction. Actually, the fluorination of benzene is very easy actually, but the reaction is violent. So how to control the reaction is described by a scientist called Siemann reaction. This is called a name reaction called Siemann reaction, in which the fluorine is introduced into the diazonium salt and slowly it is imparted into the benzene ring. A mechanics where it is slow downing the reaction actually. So finally what gets is a fluorobenzene. This is, it's a method of preparation of the fluorobenzene. So the answer goes to the C. Let's go to the next question, 15th question. The reaction of toluene with the chlorine in presence of ferric chloride gives predominantly. Here the toluene can be chlorinated in two different varieties. We have a chlorine and ferric chloride, anhydrous ferric chloride. The one Cl minus is trapped and you will get a Cl plus, which shows a ortho and the para, the attacking. So therefore ortho para substituted products will be, that is the electrophilic substitution reaction. If the chlorine is treated in presence of UV light, then the benzylic type of the substitutions we will be getting. One after the one, the hydrogens goes on, you will get benzyl chloride, benzol chloride, benzo trichloride and so on. This is the free radical substitution. So the condition mentioned is the ferric chloride, so therefore orthoparachlorotoluenes will be formed, a electrophilic substitution taking place. So therefore answer C is the right answer. Let's go for the 16th question. Fluorobenzene can be synthesized in the laboratory. It's generally from the benzene we fluorinate it, but the fluorination is a violent reaction. So therefore aniline is diazotized so that diazonium chloride is formed. Then it is treated with a mixture of BF3 and HF so that a benzene diazofluoborate is formed. So aniline is converted into first into the diazonium salt. Diazonium salt is then converted into the mixture of HF and the BF3. This you can write it as a HBF4 minus plus salt. So this Cl minus will be replaced by this BF4 minus. Benzene diazonium fluoborate is formed. This is called benzene diazonium fluoborate, a slightly unstable compound. So you go on heat it very slowly. Slow heating gives that fluorine enters into the benzene without a violent reaction. Otherwise fluorination is a damage reaction which leads to a violent explosion reaction. So therefore it is slowly we are controlling the reaction so that fluorobenzene, it is a name reaction called Siemann reaction. It's also asked in the last 2 years back also. So the answer goes to the B therefore. So let's go to the 17th question. The question is a little descriptive type, but it's very interesting. The bottles containing phenyl iodide and benzyl iodide lost their original labels. They were labeled A and B. For testing, A and B were separately taken in a test tubes and boiled with sodium hydroxide solution. The end solution in each tube was made acidic with dilute nitric acid, and then some silver nitrate solution is added. Substance B gave a yellow precipitate. Which of the following statements is true for this experiment? A is the benzyl iodide. B is giving a yellow precipitate, means B should be the benzyl iodide, A should be the phenyl iodide. So, answer A is the right answer. So, what is happening here? One is phenyl, one is benzyl. In this case, when you boil with the sodium hydroxide, hydrolysis takes place and I minus is released. In presence of silver nitrate, when you add silver nitrate, it is converted into the silver iodide. Therein you will get a yellow precipitate. Only benzyl iodide gives this reaction, but whereas iodobenzene with the sodium hydroxide, it is not that easy under the a process called Dow process, high temperature, pressure and all that is required to hydrolyze. So, therefore, phenyl iodide will not undergo readily hydrolyze, only benzyl iodide. So, therefore, the answer A is a phenyl iodide. He says that is right answer. So, answer A is right. So, let us go for the 18th question. Among the following, the one that gives positive iodoform test upon reaction with iodine and NaOH has given a different types of the alcohols. Let us go to the theory here. All the alcohols which have this type of function, this side you can have an option, it can be hydrogen or it can be any alkyl group or it can be any aromatic group. All these alcohols, when you treat it with X2, X can be a chloro, bromo, iodo. In the case of iodine, you will get a yellow precipitate, otherwise the precipitate cannot be formed. So, here the X2, this H and H will be removed and then they are converted into a ketones containing the same type of the option. Then finally, they will get the CHX3 and a ketone. Then subsequent reaction will undergo hydrolysis, you will get a CHX3. When X is equals to iodine, you will get a CHI3, which is a yellow color and precipitate. Two qualities it is. It is a precipitate, so solid, so you can go for the stoichiometric type of the applications, filter rate, weight, divided by molecular weight, you will get the moles and you can go for the calculation of the how many moles of iodoform is formed. Yellow is the color, so therefore qualitatively you can say whether the reaction taking place or not. So, what type of alcohols going to give this reaction? All 2 degree and 2 hydroxy. All 2 degree and 2 hydroxy except ethanol. Except ethanol. Ethanol is a 1 degree and 1 degree and it is a 1 hydroxy. Except ethanol, all 2 degree 2 hydroxy, they oxidize into this type of ketone. They are described as methyl ketones. One side methyl containing ketones. Except again the acetaldehyde. Except acetaldehyde, no other aldehyde will give. Acetaldehyde will give this reaction. It gives halogenation and then hydrolyzes to give this product. So, therefore, specifically with the iodoform test, it is wonderful reaction. So, all the 2 hydroxy, so identify the 2 hydroxy compound in the given. So, the last one is a phenyl containing a OH and H and a CH3. This function, wherever it is there, you can immediately say it gives the yellow precipitate. So, therefore, answer goes to the D.